Hello everyone. In this particular session, we shall discuss about the second type of assignment problem. Second type in the sense, usually we solve the assignment problem by assigning the positions which has got 0. So that in the sense we usually reduce the table and we make one of the element 0 in the row as well as column, and then we usually allocate or assign that particular position. But here when we get multiple number of solutions or multiple optimum solution, so how we solve the problem using Hungarian method. So the problem is as follows. We have jobs A, B, C, D and E. These are the jobs, and workers 1, 2, 3, 4 and 5. So there are 5 workers and there are 5 jobs. So 85, 75, all those are the all those elements. So that is in the table. So let us straight away look into the answer or how to solve this particular problem. So now initially, so as we had discussed in the Hungarian method or the assignment problem, so what we do is we select the minimum value in each row and then we subtract that element from all other elements. So then we get 1 0 in each row. So such a way we reduce the table. So let us find out the reduced table or revised table. So here 85, 75, 65, 125 and 75. In the first row we have these elements, and the smallest value in that particular row is 65. So that is why, so I subtract that 65 from all the values in that particular row. So here I have 85 minus 65 is 20, 75 minus 65 is 10, 65 minus 65 is 0. So that I have written in the first row. Similarly in the second row I have the minimum value as 66. So subtract all the elements the 90 minus 66, 78 minus 66, in that way subtract 66 from all the elements. So we get this row 24, 12, 0, 66, 12. Similar way follow the same step in order to reduce the third row, fourth row and fifth row. So here we shall now we have got all these values, that is called as a revised table. So in every row we have 0, and the condition is in every row we should have 1 0 and in every column we should have 1 0. But here the smallest element or the smaller element, so that lies in this particular position. So that is why the whole column, the entire column, so that has become 0, and in every row we have 0, but in each column we don't have any 0. So that is why we need to reduce it further. By taking by considering the lowest value in the column. So in the previous assignment problem, so we had we had come across such a condition that in a single step we arrived at a situation where in every row and every column we had a single 0. But here the case is different, so we don't have a single 0 in many of the columns. So that is why we have to further reduce the table. So now look into the column. So all the rows and all the columns, each row and each column should have 1 0 for assignment. But here all the rows have 0, but only one column has 0. So that is why select the minimum value in the column. So that is 20, 24, 18, 20 and 20. So out of that 18 is the minimum value. So subtract that element from all other values. 20 minus 18 is 2, 24 minus 18 is 6, 18 minus 18 is 0. Similar way do the same thing for the second column, the third column, fourth column and fifth column. So we will arrive at this particular situation. See, let us reduce it further by selecting the minimum value in each column. So after selecting the minimum value in each column, now select the subtract that element from all other values. So finally we have arrived at this particular situation, or we have got this particular table. So here we have got the new elements or the revised table by by reducing or by subtracting the minimum value in each row, and again further reducing it by subtracting the minimum value in each column. Now let us look into the table. So here the first row we have 2 zeros, in the second row we have 0, in the third row we have zeros, 2 zeros, in the fourth row we have 0, and in the fifth row again we have 3 zeros. Similarly, in the first column we have 0, in the second column we have 0, in the third column we have many zeros, and in the fourth column also we have 0, and fifth column also we have 0. So we have arrived at a condition where we have 1 0 or more than that in each row and each column. So that is the final reduced table. Now we shall start assigning to a particular position. So here we shall do it row wise we shall do it. Now we have to do it row wise. So here the first row we have 2 zeros, we cannot go for assignment. Again in the second row the third position, C position, we have a 0, so just assign to that particular position. Now what is the next step? We have to cancel out all other zeros in that particular column. So that is why, so once you select a position in the row where we have a 0, you just assign that particular position. So after assigning, cancel out all the zeros in that particular column. Okay, so here we have cancelled out all the zeros. So here after cancellation we have 1 0, but before cancellation we have 2 zeros, so that is why we cannot assign any of the value here in the third row. In the fourth row again we have this cancelled 0, so we cannot assign any value. So in the fifth row again we have this 3 zeros, so 1 is cancelled out, and again 2 zeros we have, so we cannot assign any of the value. So that is why I have assigned for only one position. Now let us start assigning to the columns. So here the first column we have a single 0, so that is why I have assigned over here. In the second column, B column, again I have the 0 over here, so I have assigned to that particular position, and here is an extra, in that particular row cancel out all the zeros. Already we have cancelled this, so when we assign this using this column, so I am cancelling this particular 0, strike out that 0. Now the third column, so again third column we have the assignment. In the fourth column, so we have all the cancelled zeros, we don't have any single 0. In the fifth column we have a 0, after cancellation we have a 0, so column wise we can assign it. So I will assign this particular position, so now 1 2 3 and 4, there are 4 assignments. So what is the condition? So we have to get 5 assignments. We have 5 workers and 5 jobs, so that is why for each worker we have to get a assignment, so that is why we should have 5 assignments. But here we have 1 2 3 and 4, so D, the job D hasn't assigned to any of the workers, so that is why we have to start ticking the unmarked and marked column and unmarked row. So now finally we get the values as below. See, whenever we arrive at this kind of condition, so once we get this kind of condition, next is we have to tick mark the row without any assignment. So how many rows we have? See here, 1 2 3 4 5. So out of this, fourth row does not have any of the assignment, so that is why fourth row we have tick marked. The fourth row. Similar way, once you tick mark that row, I repeat once again, once we tick mark that particular row, later wherever we have got 0, wherever we have got 0 in that particular row, so that column has to be ticked. So that column has to be ticked. So here in that particular row we have only 1 0. We have to tick mark that particular column. See here, I have tick mark that particular column, so where we have got a single 0. So in the second row, in the fourth row, I repeat once again, the fourth row does not have any of the assignments, so that is why I have tick marked that particular row. And once you tick mark that particular row, then wherever there is a 0, in that particular row, so to that column we have to put a tick mark. So to this particular column I have put a tick mark, and at the same time, when I put a tick mark to that particular column, you have to search for the position in that particular column where we have done the assignment. So here the second row we have the assignment, second row position. So here I have the assignment. Again you have to tick mark that particular row. See here, so first tick mark the row which has got no assignment, and I repeat once again, so this is very very important, tick mark the row which has got no assignment, and look into that row which we have tick marked. Look into that row where we have zeros, so tick mark that column, so here in this row we have 0 over here, so that is why tick mark that column. And once you tick mark that column, follow that column wherever we have the assignment, tick mark the assigned row, so that is why I have marked over here. This row I have marked because there is no assignment. Initially we start in that condition, later we look into the column wherever we have 0, so this column I have tick marked, I have ticked right mark, so this particular column, and follow that column wherever there is a assignment, tick mark that row. Now we have done with the conditions. We have 2 tick marks for the 2 rows and 1 column has been ticked. Now what we have to do is we have to draw the lines, or draw a line above the unmarked row and marked column. So this is very very important. Once we complete the ticking, later what we have to do is we have to draw line above the unmarked row, that is unticked row and ticked column. So I am drawing the line here. So this is the first row, we haven't marked anything, so that is why it is a unticked row. The third line or the third row is unticked and the last row is unticked. So draw the line above the unticked row and ticked column. So ticked column, so is this one. So I get this kind of lines, 1 2 3 and 4. So there are 4 assignments, we have got 4 lines. So now these values 4 10 2 4 4 2, so these are called as open values, 6 4 10 2 2 4 4 2. So these are called as open values, and these values are called as and the intersection points, we have several intersection points. And now we should write the revised table again. We have to write the revised table again such a way that the open values, out of all the open values, we have to select the minimum value. Here the open values are 6 4 10 2 2 4 4 2. Out of that, 2 is the minimum value. So we have to subtract that 2 from all the open values. We have to subtract that particular value, and the same minimum value, that is 2, that has to be added to the intersection points, and all the other values which lie under the line, so that remains as it is. Okay, later look into the row for 0, tick mark that column. So those things have been explained over here, I have already told you. Now look into the open values, select the minimum open value is 2, add this value to the intersection of lines, and also subtract the minimum value from all other open values. Now the resultant table is as follows. So I have added 2, minimum open value is 2, so that is added to the intersection points, and all other elements that remain same which lie below the line, and the open values, we have to subtract the minimum value 2 from all the open values. Finally we arrive at this particular condition. Now follow the same procedure for assignment. So assign for each row, later for each column which has got single zero. So here in the first row itself we get a single zero, so that is why I have assigned to this particular position, cancel out all other zeros in that particular column. Similar way here in the second row there are 2 zeros, we cannot assign any of the position. So here in the third row we have one position, so only 1 0, so that is why I am assigning to that particular position, cancel out all the zeros in that particular column. And in the fourth row after cancellation we have 2 zeros, we cannot consider it. And in the fifth row also we have 2 zeros. Now coming to the column wise, so here already we have assigned in this particular column. So here there are no zeros, only 1 0 we have, so that is why just assign to this particular position column wise. So cancel out this 0, so whichever comes in that row, so that has to be cancelled. Once you assign column wise, when you assign to a particular position, then you have to look into the row whether we have zeros, just cancel out that 0. In the third position there are 2 zeros, we cannot assign any values. And in the fourth we have cancelled that 0, and in the fifth also we have the assignment. So there are three positions we have got. Again we have to follow the procedure for rows. Once we complete the first allocation or first assignment through rows, then later we have to move on to the columns, and later when we move on to the rows again, we have to consider the cancelled 0. Earlier we were considering that there were 2 zeros, now it is cancelled, and when we do it for the second time, when we follow it for the second time through the row, then we will not consider this particular cancelled 0. So there is only 1 0 now. You can assign to this particular position. So that particular position has been assigned here in the second position. So now when you assign to that particular position, so this will be cancelled, other 0 next there will be no other zeros in that particular column, so that will be cancelled. Okay, so that we have to do. So this will be cancelled out. So there are 4 positions now, 1 2 3 4 positions. Again we have to follow the same procedure. So we have to tick mark the row which has got no assignment, and we have to tick mark that column with zeros, and we have to follow that column where we have the assignment. So now I will explain you again. See here, the fourth row we don't have any assignment. So that is why I just tick mark that particular row, and now look into the zeros in that particular row. 1 2 3, there are 3 zeros, first column, so you just tick mark that column. In the third column there is a 0, I have tick marked that, and also in the last column I have tick marked that because we have a 0. So in that particular row we have 3 zeros, so I have tick marked 3 columns, and the same column has to be followed for the assignment. So the first column there is an assignment here, so that is why I have tick marked that particular row. In this column, in the third column where we have tick marked, so we have an assignment in the second row, I will tick mark again that particular row. And again in the last column, the first position, so there I have assignment, so that is why I have to tick mark that particular row. So totally we have 4 rows ticked and 3 columns ticked. So next step is we have to draw the line above the unticked row and ticked column. So there are 3 ticked columns, so I will draw 3 lines above those columns and 1 unticked row. So unmarked row or unmarked unticked row we draw a line, and ticked column we draw the line. So now these are called as open values: 2 4 2 8 1 1 2 2. So those are the open values. Now the next step is, so finally find the lowest open value. So lowest open value is 1. So just subtract that 1 from all other open values, and later uh, add that minimum value to the intersection point. So that I have already explained you. So now we shall do the assignment. So here, the row wise, the first row we have a single 0, so that is why I have assigned this particular position. So I cancel out the other zeros in that particular column. In the second row we have 2 zeros, so that is why I cannot assign any value. In the third row there are many zeros, 1 2 3, so I cannot assign any value. In the fourth row we have 3 zeros, so I cannot assign any value. In the fifth row again 1 2, there are 2 zeros, I cannot assign any of the position. Now first coming to the column wise position. So here the first column I have 2 zeros here, so I cannot assign any of the value. Then in the second column also I have two zeros, I cannot assign any of the value. In the third I have this one, two zeros, I cannot assign. So here also we cannot assign because we have 2 zeros. So now we have arrived at a situation where we have multi-point optimal solution. Now you have to again go for the row wise, because we cannot consider the cancelled this thing 0. So that is why we can assign to this particular position. The second row we can mark the third position, or we can assign to the third position. So that is why cancel out other zeros in that particular column. So we have 2 assignments. Again in the third row we are not considering any of the this thing, so there are many zeros. In the fourth row again there are many zeros, we have cancelled other zeros, and again we have in the fifth row also we have this one. And now in the column wise again, here the first column, in the third column and the last column we have assignment. So now start assignment, multi-point optimal solution. So here for every column and every row, so you can assign. So there are 4 positions over here. So we have got 2 positions here. The fourth one more assignment we have assigned over here, and later either we can assign this or this. We cannot move on with the further iteration. So that is why I can assign to this particular position or this particular position. So that is why I have marked a square box over here. Same time we have marked one more position over here. Either this one or this one has to be used. Or here again, if you assign to this particular position, then only one assignment in that particular column. So again here one more zero we have. We can also use, if you are not assigning this position, we can use this. So that is why I have marked in this way. And here if you are not using this position, then you can assign to this particular position. So that is assignment. So either you can use this position or this position. Either you can use this position or this position in that particular column. So in this row you select this. In this row you can select the second row, third position, third row, second position, or this position, fourth position. In the fourth row, first position we have the assignment. In the fifth position, in the fifth row, either this, the second position, or the fourth position. So now let us look into the situation 1 and situation 2. So here the worker, first one is assigned to E, so it is 75. Second is assigned to C, second position is assigned to C, so that is in the question we have to see to that particular position. So it is 66. Third it is B, so that is 66. Fourth it is A, so that is why 80. And fifth it is D, position, so that is 112. So because since we have the multiple points, multiple zeros, so that is why we have to consider either this or this or this. So that is why we cannot further iterate it. So that is why we have considered that. So we have got, finally we have got 1 2 3 positions we get, we have found out using the allocations or the assigning to the positions using rows, columns, and again rows. We have got 3 positions. Later we need 2 positions, so that is why there are 4 positions. That is why we have selected either this or this or this or this. So that is why we have allocated or assigned to those particular positions. So either you can use the second position or the fourth position in the third row, and in the fifth row again you can use second position or third position. So what happens when we use second position in the third row as well as fourth position in the fifth row? So that is situation 1. So total is 399. Similar way here for the second situation we select 1 equal to E, 2 equal to C, 3 equal to D here, and 4 equal to A, and 5 equal to D. 5 equal to B. So slightly we'll change the positions here because we have allocated the second, we have selected the second situation where we have these allocations. So finally find out the total value, that is 75. Add all those, we'll get the minimum value as 399. So one and the same, if you allocate or if you assign to this particular position or the third row B position or the D position, or here in the fifth row B position or the D position. So any position if you assign, in both the cases we get the same value. So this is called as multi-point optimal solution. So this is called as multi-point optimal solution. Thank you.